Okay, also, like I said, 9.5 is properties of logarithmic functions. And these pretty much mirror exponent rules, okay? So first property mirrors the product rule of exponents. When you multiply variables, you add the exponents. So that's what this property is doing for the logs also. So this is the product rule of logarithms. So y'all, the product rule tells me if I got a log of a product, I can rewrite this product as a sum of the logs. I can do log base A of M plus log base A of N. So it's almost like you're distributing that log to both factors, okay? So rewrite that as a sum, and we're done. Next, we have what we call the power rule of logs. So the power rule is like when you had a variable raised to an exponent that had an exponent outside the parentheses, you multiplied those exponents. So this rule sort of mirrors that. So if I got log base A of M to the P, basically I bring that P down and write it as a product. So you get P times the log A of M. So y'all, basically all you're doing on that power rule is you're bringing these exponents down to the front of the logs. And then we'll go through examples doing all these, y'all. So next is the quotient rule of logs. So the quotient rule is for division. So if I got log base A of M divided by N, I would take the log A of M minus the log A of N. So when you divided variables, you subtracted the exponent. So when you rewrite a log of a quotient, you rewrite it as a subtraction. Now the fourth one is just a property to help us simplify our answers. So this is the log of a base to a power. So if I have something like this, log base A of A to the X. And y'all had examples the other day doing problems where the bases matched raised to an exponent. The answer was always that exponent. So if we come across something where the base matches the result raised to an exponent, then we have to simplify that to just the exponent on those, okay? So keep up with these properties because we're going to use these on these problems they're about to give us. Now, I'll tell you what they're going to do on these problems. They're going to give us one doing it with logarithms and then one doing it with the ln, which is the natural logs. Okay, so these first examples say express as a sum of logarithms. Well, the one that expresses things as a sum is the product rule. So they're going to give me a product and I rewrite it as a sum. So for one, they got log base 22 of 22 times 484. And y'all, what's nice on this one, they don't want us to simplify, they just want to rewrite it as a sum. So basically, you're applying your log base 22 to each factor. So you'll get a log base 22 of 22 plus a log base 22 of the 484. So I've rewritten this product as a sum. That's all I needed to do. So we can move on to number 2. So number 2 is the same thing, except they're giving us the ln. So this is the ln of b times c. So remember, ln is just a log base e, okay? But that don't matter on these, because all you're going to do is rewrite this product as a sum. And remember, the ln affects both of these. So we'll have the ln of b plus the ln of c. We've now rewritten our product as a sum, and we move on. So it's not too bad if you keep up with your little rules up here, okay? See y'all in a second. So the first 2 was expressed as a sum. So 3 and 4, they want us to express as a product. So to express things as a product, you're going to be doing the power rule. That's where you're going to bring that exponent down to the front and rewrite it as a product of that exponent times that log. So for 3, they give you log. Let's see, what's that? Log base 10 x to the 15th. And really, the only thing you got to do to express this as a product is bring that exponent down to the front so that you get 15 times the log base 10 of an x. You know, that's all we do on that when we rewrite it as a product. All we're doing is bringing exponents down to the front. Now, number 4 is a little trickier. They got the ln of the 4th root of 6. All right, so that's a 4 there. So y'all, the trick on this, the first thing you want to do to this is rewrite that radical. So rewrite the radical as a fractional exponent. So I'll bring down my ln. My 6 is the base under the radical. Oh my God, y'all are doing pretty good. Good job on that chat. Because remember, to rewrite the radical, you rewrite it as a fractional exponent. It's always 1 over whatever your little index is. And good job, because what'd you do? You just brought that exponent down to the front and gives me a 1/4 ln of 6. Oh, good job. And y'all, here's the rule for the rewriting the radicals. It's always equal 1 over whatever that little index is, okay? All right, so look, we've done the product rule with the first 2, power rule with the next 2. Now we're going to do the quotient rule on a couple of these, okay? So let us get ready for the quotient rule. These ones will say, express as a difference of logs. So y'all, 5, they got log base r of d over 3. Now here's the thing, you distribute that log r to both of the factors on top and bottom, and it's always the top minus the bottom. So whenever you have fractions, the tops are always positive, and those bottoms will always come out as negative, okay? So this one is just going to be what? A log base R of D minus a log base R of 3. Now, y'all don't get more work on these as we go. They just wanted y'all to get the basic knowledge on these first 6. All right, y'all want to try this one? I'll let y'all try this one. I got an ln of m divided by t. So I'll let y'all chat me that answer real quick, see what y'all get. Oh, y'all, let me get y'all on that, huh? So let me see what I see. Ln minus the ln that's it. Ln of m minus ln of t. All right, so now they're going to sort of turn it up a little bit. They want us to rewrite as sums or differences of logs. And y'all, I'll tell you what, all 4 of them properties are now in play, okay? So number 7, they're giving us the ln. It's the ln of x to the 4th, y to the 6th times z. So since we have a product here, our first step is to rewrite as sums. Now, if this was being divided, then I'd rewrite it as differences. But these are all being multiplied. There's 3 factors, the x, y, and z. So all of them have to be added. So I got the ln of x to the 4th, plus my ln of y to the 6th, plus my ln of z. So we don't have to do differences on this one because there's no dividing. But y'all, there's one more thing I got to do to this answer to be in final simplified form. And it has to do with that power rule. Since I've got variables with exponents, I now have to move exponents to the front of the logs using the power rule. So anytime you finish these problems, you've got to make sure the exponents are sitting down in the front so that you get a 4 ln x plus this one will give me a 6 ln y. And then the last one didn't have an exponent that we had to worry about, so that stays at ln z. So now that my exponents are all moved, this is my final answer. So these aren't bad, y'all. You just got to keep up with the steps because notice nothing goes away. You're just rewriting it every time, okay? So here comes a good one. Put a star by number 8 because this is a tricky one. I got a log base b, p to the 4th, q to the 5th over m to the 3rd, b to the 9th. Now, here's the trick on this one. The 2 factors on top stay positive when I rewrite. The two factors on bottom, since they're on bottom being divided, they will be negative. The two factors on bottom will be negative. And y'all, that's how it's going to be every time. The top factors will always be positive when you rewrite it. The bottoms will always be negative. Now we distribute the log B to all four of these factors. So we'll have a log B of P to the fourth plus a log B of Q to the fifth. That takes care of the two factors on top that we said would stay positive. Now the two factors on bottom we said would be negative. So you bring down your negative and then your log B of M to the third minus your log B of B to the ninth. So guess what? Next, we're going to move all these exponents to the front for three of these. But y'all look here at the end. This is a log base B of B to the ninth. What does that simplify to? So say that was a log base 10 of 10 to the ninth. Remember that fourth property we looked at when I gave you those four properties? This is the same as the log of a base to a power. Well, you got the whole answer. Good job. So it turns into a 9. Good job. So at the end, I'm going to be subtracting 9. So it looks like, oh, you got that all wrote down. So 4 log B of P, so move the 4 down, plus 5 log B of Q. So that looks good up there. Minus, what do you get next? 3 log B of M. And then at the end, good job, that is a minus 9. Oh, that's tricky to write all that. But that's a good job. So that's what we talk about. Final simplification. Exponents are all brought down, and then we simplified that log B of B to the ninth. Well, y'all, same thing with 9. They're going to use the ln this time. Ln of 2 divided by 9x squared y. And I'll tell y'all the truth on this one. What gets people on this one is they don't realize that's really 3 factors on the bottom. That's a 9, a x squared, and a y. I have people that try to put the 9x squared together, but no. These are 3 separate factors on that bottom. 1 factor on the top, 3 on the bottom. So guess what? All 3 of the factors on bottom will be negative because those are what's being divided by. So same thing again. Factor on top positive, factors on bottom negative. So y'all will have a ln of 2 minus ln of 9 minus the ln of x squared minus the ln of the y. Now, I've got everything rewritten, but I got one more step to do. And my last step is to take that 2 exponent and bring it in front of its ln. So I get a ln 2 minus ln 9 minus 2 ln x minus the ln of y. Whew. Davis, you're on the roll because that looks good on there. So good job. And y'all, that's really the trick on these is keeping up with the exponents and then Remember that the tops are positive and the bottoms are negative on these, okay? All right, so I'll probably have to move this back up. Let me see. All right, so this is like number 10 here. So they're going to get tricky for a few of these. So 10, they have a log of a square root of C, looks like to the 6 times a D. So the first thing I would do to that, rewrite the radical as a fractional exponent. Now remember, you got two things under that radical, so when y'all rewrite that, you're going to have your log. You're going to have to put that C6D in parentheses and then figure out that fractional exponent, because that exponent has to affect everything like it did up here. So y'all, what does a radical without an index turn into as a fraction? Well, y'all, the top number is going to be a 1, remember? Oh, good job, y'all. If there's not a number in the notch, it's automatically a 2. All right, so now the next step we would do, we would actually multiply. Now remember, the D has an exponent of 1 behind it since we don't see that. And what you're going to do is you're going to multiply the exponents inside the parentheses by that exponent on the outside. That's what we call the power rule of exponents. Exponents raised to an exponent, we multiply. So y'all, let's see what that gives me. I got a C, 6 times 1/2. Well, 6 times 1/2 is 6/2, which will turn into a 3. So I got C to the 3rd. Now the D, I got 1 times 1/2, which is just going to stay 1/2. So y'all, I haven't done anything with my log yet. All I did was rewrite the C to the 6D under the radical. It finally simplified to a C to the 3rd, D to the 1/2. So since these are being multiplied, we rewrite as sums. And really they're both on top, so they're going to both be positive anyway, right? So you get a log C to the 3rd plus a log D to the 1/2. All right, y'all, my last step. Bring these exponents down to the front. So that's going to give me a 3 log C plus, that's going to give me a 1/2 log D. And I'll tell you what they're doing now. They're doing the same rules, but they're throwing these little radicals at you so that they can try to change up these problems a little bit, okay? All right, here's the second star. Here's the second big one, okay? So y'all, we have some work on this one. This is a log base C of the 4th root of a M8 N20 over a C7A5. And y'all ain't gonna lie, the first thing I gotta do, rewrite that radical. As a fractional exponent. So bring down your log base C So I know the exponent is going to affect everything that was under it. So it's going to affect the M8, N20, all divided by the C7, A5. Question is, what's that exponent going to be after I rewrite that radical? All right, so let me help you out. We know the top's going to be a 1. Since my index up here was a 4, that means this fraction will be a 1/4. Okay, so remember, radicals always end up as fractional exponents. Now what you got to do is distribute that exponent times every exponent inside this parentheses. So you got 8 times 1/4. That'll be 8/4. That turns into a 2. So I got an m squared. N is going to be 20 times 1/4. That's 20/4, which will equal 5. So for the n, the exponent will be a 5. All right, so for my c, I got 7 times 1/4, which will give me 7/4. Y'all, I cannot reduce that any, so the c will stay 7/4. And then my a here, my a had 5 times 1/4. Well, y'all, I can't do nothing to that. That's just going to stay 5/4. So my a gets a 5/4. All right, so all this we did, all we've done so far was rewrite this thing without that radical. Now, if it's on top, it's positive. On bottom will be negative. So these are going to be positive factors. And the ones on bottom are going to be negative. Now remember, we got to distribute the log C to everybody. So here we go. We're going to have a log base C of m squared plus a log base C of n to the 5th. Those two were on top. We said those had to be positive. Now, we're going to have minus a log C of C to the 7/4 minus the log C of A to the 5/4. So these two we said would be negative. There we go. So here's the thing. This one, I'm going to bring the exponent down. This one, I'm going to bring the exponent down. And the last one, I'm going to bring the exponent down. But y'all, you got this part here. Log base C of C to the 7/4. What does this thing here simplify to? What y'all think? So that, good job. That's going to actually be just a 7/4. So this third term, I'm just going to make it a 7/4 and then move on. So bringing the 2 down, you get 2 log C of m plus bringing the 5 down, you get 5 log C of n minus 7/4 and then minus, bring that 5/4 down. So you get 5/4 log C of A. You know, what makes these problems sort of seem long is you're really not getting rid of nothing, you're just rewriting it. There's no more simplifying because none of this stuff is what you call like terms or anything like that. So y'all, what they're going to do now, this we wrote as sums or differences. Now they're going to give me sums and differences and have me try to rewrite that as a single logarithm. So let's see, these ones will say right as a single logarithm. And then if possible, simplify. So simplify if possible. So we start at number 12. So 12 had a log base C of 67 plus a log base C of 59. So since they're being added, we rewrite these as a product. So these will write as a product. So bring down your log C. The product is going to be 67 times 59. And y'all, to simplify if possible, well, we can multiply 67 times 59. And that actually gives me a log C of 3,953. Oh, you already beat me, dude. Good job, Karen. So 39, good job. Now, watch this one though. I got log of 100 minus the log of 10. So since these are being subtracted, y'all, you're going to write this as a quotient. So remember, it's always the positive on top, the minus stuff goes to the bottom. So this will be the log of 100 on top over 10. Well, y'all, that can go further. I can simplify because I can divide 100 by 10. 100 divided by 10 is 10. Can you go further? So y'all got a calculator. What do y'all get when you punch in a log of 10? Just using that log up on the front of that calculator. So, well, y'all quick. Y'all got ones popping up. Good job. Because remember, that's like a base 10. And anytime the base matches the result, you're going to get a 1 out of that. Oh, this one might be sort of tricky. 1/3 log C of X plus 5 log C of Y minus 4 log C of X. So since we're going in reverse, our first step is to bring the exponents up to the variables. Since that's usually the last step when you're going the other way, that's the first step going this way. So bring the exponents up so you get a log C of X to the 1/3 plus a log C of Y to the 5th minus a log C of X to the 4th. So bring the exponents up. Up behind the variables. Now, remember, the positive stuff when I rewrite this will be on top. The negative stuff will be on the bottom. So you got your LC, your log of C. On top is the X to the 3rd times the Y to the 5th. So the positive stuff become a product on top. Now this part we're subtracting, that X4 goes to the bottom. Okay. So remember, positive factors on top. Negative factors on that bottom. Now, y'all, technically we would be done, but we got an x to the 1/3 sitting over an x to the 4. That needs to be simplified. So this part right here, these single x's has to be simplified. So the rule for simplifying variables with exponents. Oh, David, you're doing good. It's always, so you took the bigger exponent was the 4, you subtracted 1/3 from that, and then you leave it in the bottom since it was bigger in the bottom. So she brought over that log C. The top was going to stay Y5. And then since the x's were bigger in the bottom, you have to take 4 minus 1/3. Well, remember, that's like 4 over 1. So common denominator would be 3. So this one, we would multiply top and bottom by 3. So 12/3 minus 1/3 gave her 11/3. So that x stayed with an 11/3 for the exponent. Ooh, good job. So you probably like this section, don't you? All righty, y'all. So let's see. Now x's and y's don't match, so we don't go no further on that, okay? All right, let me see what I got next. What's this? What was that? 14, so I'm on 15. All right, so watch this. And 15 has an ln x to the 6 minus a 3 ln of a cube root of x to the 5th. So before I mess with anything, I'm going to rewrite the radical as a fractional exponent. Now, y'all, this is a cube root of x to the 5th. So when you rewrite this, since it's got an exponent by the x, that exponent will be the top number of the fraction. And the bottom number will still be the 3. So a cube root of x to the 5th will simplify to an x to the 5/3. So just remember, this exponent still stays up high. The index becomes the bottom of it, okay? So doing that gives me an ln of x to the 6 minus 3 ln of x to the 5/3. So remember, my first step was to bring these numbers up. So when we bring that 3 up, it gets multiplied by the 5/3. So let's see, 3 times 5/3. You all guess what's happening there? Those 3's cancel, leaving me with a 5. So when I bring that 3 up, I now have an ln of x to the 6 minus, this became an ln of x to the 5th. And y'all, yours are gonna, they might not use 3's on y'all's, they might use 5's, 4's, 2's, or whatever. But whatever's in front, when it multiplies by that exponent, it's going to cancel like mine did. And you'll be only left with the 5, okay? All right, now, top will be positive. Negative stuff goes to the bottom. So this will be an ln of x to the 6 on top. The x to the 5th goes to the bottom. Oh, look at that. I will get a ln of x because 6 minus 5 leaves me just 1x. You know, it's tricky on these, but get them radicals gone, pull them exponents up, and then positive factors on top, the stuff being subtracted to the bottom, okay? And then at this point, we just subtracted exponents. So x to the 6 over x to the 5 just left me an x to the 1, which was the x. So let's see how y'all's factoring does. So this one has an ln of x squared plus 10x plus 24 minus an ln of x plus 6. So y'all, nothing we can do inside the parentheses. There's no like terms. So I'm going to rewrite this as a single log. So remember, the positive factor goes to the top, x squared plus 10x plus 24. The factor being subtracted goes to the bottom, which will be my x plus 6. So the trick on this one, we need to simplify. So what we got to do now is factor the top of this. So I know the top will factor into 2 parentheses. Now the bottom, you can't do nothing, so that's going to stay x plus 6. So y'all, x squared means an x and an x. That 24 is positive, so both factors will be positive like the middle number. Now, if this is going to simplify, one of these factors better be a 6. And let's see what y'all got. Y'all got 4 and 6. Good job. And guess what? Now, since I got factors that match, this factor on top cancels with this factor on the bottom. And since I no longer have a fraction here, I need to keep my x plus 4 in parentheses for this answer. So, Davis, remember when you do math lab, keep that x plus 4 in parentheses, or it'll treat it like the ln of x and then plus the 4. But remember, we got to do the ln of the x plus 4 as a sum, okay? So, y'all, that's what you got to watch for on 16. You got to do a little factoring on top so that you can get stuff to cancel. And then 17 is going to be the same way. So let me see. 17, I got log. And notice they're switching back between that log and that ln on you. X squared minus 5x minus 14 minus the log of x squared minus 4. So at the moment, I can't do nothing to these. There's no like terms in the parentheses. So I'm going to rewrite it as a single log. Positive factor goes to the top. X squared minus 5x minus 14. The factor being subtracted goes to the bottom. So this one, since you got x squareds on top and bottom, we got to factor the top and the bottom. We got to factor both of these to see what's going to cancel. So the top will factor into parentheses. The bottom will factor into parentheses. Y'all, you just got to treat the bottom like a 0 in the middle for the x. You got your x squared term. Oh my God, y'all are blowing this away. So let's see. Factor to 14, that'll give me a 5. Y'all got a 2 and a negative 7. Good job. Unlike signs, larger factor like the middle. And then you got 2 and negative 2 on the bottom. Good job. So the perfect squares like the bottom always end up whatever the square root of that number is in each parenthesis. All right, so guess what? This one we can cancel out the x plus 2's. So we're going to end up with, now since we got a fraction left, you do not have to put things in parentheses. So that we get an x minus 7 on top, x minus 2 on the bottom. Since it's a fraction still, the math lab would know that technically there would be parentheses around that top and bottom. But y'all, the one that I did over here, this 16, you definitely got to keep that one in parentheses, okay? Because it didn't have the fraction left. So y'all, that's your trick on those. So keep your properties by you. And that's all I'm going by when I do these, okay? Remember, Switch them radicals into fractional exponents when you need to. And these things won't be that bad. Okay. So let me ask y'all, any questions on this? Y'all, I'm not seeing no questions. So this week's not bad. You just had the 9-4 stuff we did Monday and this 9-5 stuff. Next week we do 9-6 and 9-7. Then you got Thanksgiving break. Once we come back from break, we're going to study for test 4 and then start studying from a final, okay? So we really don't have a whole lot of time left in this class. All right, y'all, so let me stop my recording.